So my talk is called How Python Drives Modern Data Engineering. So let's talk about what you can expect from my talk. So this is the part where I tell you what the value proposition of my talk is. Okay, because you're here, you've spent time and effort to be here. So now it's only fair that you know what you're gonna get out of my talk. Okay? So let's talk about the main points. First thing is I'm going to introduce what modern data engineering is. Okay, so a lot of people have a lot of misconceptions about it. So let's hash some of them out today. Okay, next thing is I'm going to talk about data engineering on the cloud. Okay, so keyword modern, and a lot of you are probably aware that when you say modern, you are also thinking about the cloud. Okay, so we're going to talk about that, but we're not going to leave the on-prem systems in the dust. We're also going to talk about that. Okay. Next is we are going to describe common business use cases. Okay, so at the end of the day, you have to understand what your value proposition is to the client. Otherwise, if you don't have value, if you don't provide value, then what's the point, right? So we're going to discuss common business use cases that is prevalent in the data engineering space now. And then finally, I'm going to show you how Python is used in the modern data engineering tech stack, which is what we came for here today, right? Okay. So the abstract says it all. So mayhaps you've already read it before the talk. So what's important to note here is that we want to see exactly how Python integrates itself with the discipline of data engineering. So if you are somebody who's trying to figure out what else to do in their career path, like maybe you figured that where you are right now is not where you want to be, or you are already in this space and you want to either update or add your knowledge, then this is exactly for you, right? So what I like to call Python is it's every man's language. I call it every man's language because anyone can learn it. Kids are being put to coding school. Probably when they're children, they learn Scratch. But when they are of age, they learn Python. It's extremely easy to learn. It's almost like reading a plain English sentence. But the more important question here is, how far can Python take me? Okay? It's easy to Google, what's Python? It's a programming language, okay? But the better question is, how far can it take you in your career and in your goals and aspirations? So it all boils down to what exactly it is you want to specialize on. So some examples. The cloud. So a lot of you probably work on the cloud. You have Google Cloud, you have AWS, and you have Azure. You also have Snowflake. So a lot of you, regardless of whether you're a software engineer, infrastructure engineer, platform engineer, security engineer, you probably worked on the cloud or will end up working on the cloud. Okay? Next thing, hot topic, ML, AI ML. So recently you have ChatGPT making waves, and you have a bunch of other things that are coming out of the woodwork. Okay? So everyone wants to get into ML these days, and a lot of ML is driven by Python. PyTorch, TensorFlow, Jupyter Notebook, all compatible with Python. And then you have your normal SaaS, PaaS, IaaS applications, web applications, mobile applications. SaaS, software, PaaS, platform, IaaS, infrastructure. So all of those things can be driven by Python, right? From the networking down to the processing to the fulfillment engine, everything is on Python. And then a direct offshoot of that is IoT. You have embedded devices, your phone, your GPS, your smartwatch, all of those things that connect to the internet that is mobile can fall under IoT. You can become an IoT engineer. But what we're focusing on today is something that is a little bit, I wouldn't say it's obscure, because it's actually gaining traction. but something that everyone wants to get in. I would say it rivals the demand for data scientists now, okay? So you have data engineering. So then that brings me to my to the next section of this talk, where I introduce it, okay? So there might be confusion, right? What's a data engineer and how does it differ from a data scientist? Maybe you went to an interview and the person wanted to test you. So what's the difference between a data engineer and a data scientist? Okay, that's a common interview question. They just want to test to see how deep your knowledge is. Okay, let's kick it up a notch. What's the difference between that and a machine learning engineer? Okay, so you have a data scientist, but you also have a machine learning engineer, and both do ML. So what's the diff? And then you have your umbrella term. You have the software engineer. So it's a funny term because they can give you that title and make you do whatever, right? Because it's so broad. And then you have the cloud engineer. It's basically someone who works on the cloud, right? So I'm going to very concisely define what the differences are. Difference between data engineer and data scientist. The data scientist does all the cool stuff. They build the models, they do the statistics, they find the business insights. But the data engineer makes it possible for the data scientist to do that by preparing the data, make it ready to use. The difference between a software engineer and a cloud engineer. Software engineer is a blanket term, like I mentioned earlier. So if you're not careful, they could give you that title and make you do all kinds of things. So you have to check the job description, basically. Cloud engineer, basically someone who works on the cloud. Again, AWS, GCP, Azure, Snowflake. And then finally, machine learning engineer. This person productionizes ML models. Okay, so the data scientist creates your model, then the MLE takes that model and productionalizes it and makes it available to everybody. Because remember, your data scientist could have a notebook with a killer model, but if it never becomes available to the public, then it's as good as useless. That's why you need an MLE, to make it available to everybody and to realize value for your business. So let's dive into the definition a bit more, okay? So in very simple terms, a DE is someone who makes sure data is ready to be turned into something valuable for the business, okay? That's the whole premise of big data. Companies have a lot of data and they collect all your information. So how exactly do they create all these targeted ads? How do they recommend shows on Netflix and HBO? This is how they do it. They harness the power of big data, okay? And in order for it to become possible, we have to curate that data. Okay, so some examples of value realizations are the productionized ML models, again, and then reports on Looker, Power BI, etc. Reports, meaning dashboards. So you might be, if you're a visualization engineer, this is exactly what you do. You create a dashboard with a bunch of key insights pertaining to the business, and that is what businesses use to make data-driven decisions. So in a nutshell, we design and we build ETL/ELT pipelines. What does ETL and ELT mean? E stands for extract. Extract meaning you ingest the data from somewhere. Could be an API, it could be a database, it could be another data warehouse. T stands for transform. So you take that data, you fix it, you consolidate it, aggregate it, until it becomes usable. And when you're done with all that, you load that data into a data warehouse, ready for consumption. Okay? So ELT is basically just a reversal of the last two steps. Instead of transforming before loading, you load and then you transform within the data warehouse. So which to use? Well, that's a topic for another day. But in general, that's what you do. Okay? So more than that, we are concerned with scalability, resource optimization, and time optimization. Okay? So in simple terms, that means if tomorrow I wake up and 1 million requests come in, the system should not go down. Otherwise, the system is flawed. It's not optimized. And it needs rectification. Okay? So you need to understand how many resources you need that isn't too much but not too little. Because if you have too much, you're gonna you're gonna overspend. If you have too little, then your systems would go down eventually. And then time, of course, you have to consider your SLA, service level agreement, which is defined before you sign a contract with the client. The client says, I want my SLA to be under 10 seconds. I send the payload and it has to be processed in 10 seconds. Okay, so that's a sample SLA. Not all SLAs are that strict. You could have a 10-minute SLA, 15-minute SLA, etc. So another responsibility is for you to make sure that you hit those SLAs. Otherwise, that's a breach of your SOW. Another thing is we handle migration from on-prem systems to the cloud. Okay, so now we're coming into the age of the cloud. So before today, or not before this era, I would say, what companies did was centralize data warehousing. So they would actually provision their own data centers, buy their own hardware, their own servers, and handle everything from the operational expense to the capital expense. Okay, now we're moving on to the cloud. So we are housing our data not just in one proprietary data center, but we are now housing it in the public cloud in multiple geographical locations for maximum reliability and scalability. And another thing we do is we design the technical architecture for how data is moved and processed between services. So you might be used to, in a sprint, you have a feature. You get a card and you just do the card. But you're not exactly sure how it fits in the whole picture. Sometimes it's like that. Sometimes, if you are a DE and you're in charge of doing the TA, you have to understand exactly how the data ebbs and flows within your system. Okay, and then you would have to design a TA, which you would then propose to your client. Okay, you have to defend why is this robust? How do you know it's scalable? And how do you know it can handle all kinds of data that we throw at it? Okay, and then next thing you do is you clean data and you ensure data quality. Okay, so there's a lot of data in the world, but a lot of it is also dirty and nonsensical. Your job is to clean it out. So clean, simple example of clean or a process which cleans the data is you could look at this column and then convert all of the integers into strings. Could be something like that. Or you can find misspellings. Or you could apply a business rule to weed out redundant data. Okay, so that's how you clean data. And then a direct sibling of that is to standardize data according to business requirements. Okay, so there's no one way to standardize data because there are different rules for each company. So let's talk about Python on-premises first. So let's start with centralized data warehousing and then move on to the cloud. Okay, so some of you guys might know these technologies. You have Hadoop, Apache Spark, Teradata, and those are just a few technologies of all the technologies that used to exist before. I mean, it exists now, but a lot of people are migrating from these technologies. Okay, so all of these are compatible with Python. But a lot of you, if for example, you have worked as a DE in the past 10 or 20 years, you might not have used Python with these technologies. But these are data processing technologies that are used to curate data on premises. So now, when you go to the cloud, the first thing you need to look at is the cloud provider. But more or less, the services are all the same with a different name, right? So you have AWS, you have Lambda. Lambda is a serverless function. So what it does is you have a code, you run it, and you don't have to worry about provisioning a server. Okay? So these serverless functions are what you use in microservice architecture. Microservice architecture meaning you break down your processes, your business processes into little functions, and then you run them ad hoc. Okay? And then you have Glue. Well, these might be foreign to you all, but what it basically means is Glue is how you transform data on AWS. Well, there's many ways, but this is one of the ways. And we use PySpark. Okay? So PySpark is Python and Apache Spark together. And then you have Redshift. Redshift is AWS's main data warehouse. This is where you house all your data, your stored procedures, and where your consumers pull the data most of the time. It could differ, but this is the most common way we do it. And then you have Google Cloud. You have Cloud Functions, which is the direct competitor of Lambda. Same concept, serverless function. All you care about is the code. You run the code, and that's it. You don't care about provisioning servers. You have Dataflow, direct counterpart of Glue, written in Python or Java, but mostly Python. Then you have BigQuery, which is Google Cloud's version of a data warehouse. Again, this is where you put your data for consumption, and this is where you house all your stored procedures. Okay, and then you have Azure. Same concept. You have Azure Functions, Data Factory, and Data Warehouse. It's very self-explanatory. So these are just a few services of all the hundreds of services on the cloud that use Python. These are the most common services we use when we want to execute data engineering jobs. Okay? So if you have plans of shifting into this space, I would suggest pick a cloud provider of your choice, doesn't matter which one, and start with those 3 services. So use this as your guidepost if you want to beef up your resume and apply for a DE role. This is what you need to learn. Because once you learn this and you branch out to other services, it'll be a piece of cake. So start with the fundamentals. Okay, so now let's go into what we mean by modern. So the classic debate, right? Cloud or on-prem. Classic debate, black or white. So you can have your data on the cloud, you can have it on-prem. So then you might be asking yourself, what's better? Is it better to have it purely cloud native? Is it better to have it purely on-prem? Well, with everything I said earlier, it's very, based on what I said, the obvious choice is cloud, right? Based on what I said, but it's more nuanced than that. So the answer to that is that, let's look into this Gartner article. So you don't need to read everything. I just want to direct your attention to that last sentence over there in the yellow box. It says, by 2025, 51% of IT spending in these 4 categories will have shifted from traditional solutions to the public cloud. So based on all the things I'm feeding you, you're probably going to be inclined to say it's the cloud, but it's not as black and white as that. Usually, in the modern DE space, we're dealing with a hybrid system. Why? Because a lot of companies which are older than you and me, with systems older than you and me, have on-prem systems, right? It's not that easy to migrate everything to the cloud. It's extremely costly. And if you do not optimize your strategy, they're going to lose a lot of money, okay? So the sweet spot here, the best risk to return balance would be if you go hybrid. You can keep all of your sensitive data, like credit scores, addresses, anything that is PII, or personally identifiable information, on-prem, if you're really tight-lipped about that. But you can keep everything else, all the other sensitive-ish data on the cloud. So then you get to streamline your processes. You can harness the power of big data, create models, create dashboards, etc. Now that we've answered that question, let's go into some common business use cases. So oftentimes, the clients that we get are companies with scattered data sources. When I say scattered data sources, I mean they have spreadsheet upon spreadsheet upon spreadsheet with different formats housed in different databases coming from different sources, like different third-party partners, something like that. Okay. They have years worth of data, but they don't know what to do with it. But they recognize that they could possibly use this data to get ahead of their competitors. So just to paint you a picture, a client could have data in a SQL Server, in an Oracle database, in a file storage, all with different formats, all with different contents. So they don't need to churn all of this data over and over again. We can just understand the business requirement and then build the pipelines that would automate this whole process. So that's why it's so in demand, because people are losing time and money on trying to understand all of this data. So let's do a little bit of TA. Okay, so TA. So let's pretend this company has these data formats. You have the spreadsheet, the CSV, the text file, the JSON. Okay. So what we want to do in very simple terms is just do magic with that. Okay, do magic, then profit. Okay, that's a very simple way to do it, but it's not as simple as it sounds, right? So what the architecture could look like is something like this, or rather what your code would look like if you want to take a stab at it with just one whole script. So again, you have CSV, JSON, spreadsheets, and text files. So what you would do is you know that this is structured data, right? So you would say, okay, let's import pandas. Make it easy for us, let's import pandas. Then import JSON. Let's say we're going to deal with the JSON files first. So what you would do is you're going to talk to the analysts and ask them what do they do with all this data and translate it into code. Okay, run your script and then your data will be clean after that. So that's a very simple way to do it. But in practice, it probably looks something like this. So you ingest that data into your bucket, your AWS bucket. So if you don't do AWS, a bucket is just an object storage. You can upload files, you can upload images, videos, anything on your bucket. Okay, it just houses data. Then you have AWS Glue. So again, going back to what I said earlier, it is the service of choice when you want to transform data on AWS using PySpark. Okay? So, okay, write your glue script in PySpark. Transform, aggregate, consolidate, join with other data. Then when you're done with all of that, load it into Redshift, and there it can be consumed by other analysts, data scientists, software engineers, etc. Ready for consumption na siya. Okay? And usually, that's where the contract ends. The part where you load that curated data into Redshift. Another contract, your company could sign another contract, right? So I have all this curated data now. How do I realize the value of that data? Like you keep rehashing, right? So another contract. Okay, get a team of data scientists to work on that curated data. Or get a team of visualization engineers to create dashboards out of that data. And then, there you go. That's how they get their money's worth. So now, another type of company that we cater to is the company that needs their data ASAP. Okay, so now this is not much a problem of technicality, but rather a problem of optimization. Okay, so you have the time, it's time sensitive. Okay, so time matters. Resourcing also matters. So that's where the challenge here lies. Okay, so what we're going to do is, again, we will build the pipeline, but design it to make it fast. And we're going to design it to make sure that if, again, I get 1 million, 2 million, 3 million, 4 million requests tomorrow, it will not go down. Okay? So same concept, but we are focusing on a different aspect in this situation. Let's do TA again. You have mobile data or web data. This is very common with e-commerce setups. So your app, whether it be on the web or whether it be on mobile, it gets sent to the cloud. Okay? So you click track, or rather you click checkout, and then automatically your data goes on and is fed to a certain API, and then goes onto the cloud. Okay? And then magic happens again, right? So then what happens next is you re-release that data back to the customer or the consumer, or maybe you do a bunch of other things with it. Like for example, say checkout. And then within 5, 10, 15 seconds, you get the confirmation. So that's what's happening in the background. If you do it fast, if you do it efficiently, then customers are happy. And then, obviously, the direct outcome of that is our balance sheet is nice and green. Okay? So let's take a look into that black box. Between the two phone icons, that's what you see. That's what happens in the black box. Not all architectures look like this. This is just a sample architecture, by the way. Okay? So since we're dealing with small amounts, like the volume is small, but the frequency is like fast, like maybe every second, maybe every millisecond. So what we want to do is we want to use PubSub. PubSub is a way to collect and distribute data that are large in volume. So it's extremely scalable, and it's commonly used in cases where you have to deal with time-sensitive data. Okay? So now you stream that data into data flow, which again is what you use to transform data. And to use data flow, you have to know Apache Beam, which is compatible with Python. So that's where all of your Python knowledge would come in. Okay? Then once you're done with the transformations, load it into BigQuery. And then you can re-release it back to the customer. So using PubSub again. Okay, so your curated data is now in BigQuery, like maybe something simple like an order confirmation. And then PubSub would then take that data and redistribute it to the customer. So then the customers would then receive that notification that, okay, so my order's been processed. So I'm right on the dot. So I entered this talk posing a question. You have to think about it with yourself in mind. How far can Python take me? Okay. So my goal is to give you an idea of how far it can really take you. And I'm heavily implying that it will take you far in the data engineering space. Okay. But other than that, I hope that it's given you options, especially if you are thinking about shifting specializations. Okay? So hopefully after this, you have an answer to the question of how far can Python take me. Thank you.
I'm Jazri Arceo, Ray. So my question is, we've been talking about like all of these are proprietary things, right? So we had AWS, we have Azure, we had Google. So for beginners who are still exploring on data engineering, so do you have any suggestions of open source libraries or open source like tools that they can use so that they can begin like they can start on data engineering for example, if they want to try on stuff?
Okay, that's a great question. It's good that you mentioned that these are proprietary. Like a little note on that, they are proprietary, but they built on open source technology. And they just made it widely available and started selling it. So, well, what I would say is, I would assume that you know Python, right? But then you need a little bit of guidance of how to use Python exactly. Okay. So what I would say is, though AWS and Google Cloud and probably Azure too have like a trial. So you're aware of the trial, right? What I do personally is I like to cheat a bit, like, okay, trial, $300 credit. When it's done, I make another account and then do another trial and over again. And I usually I port my code into the next environment that way. But other than that, I would say one thing that you can do without cheating it is to brush up on SQL, for sure. So what exactly about SQL, right? So what I would say is start with understanding normal stored procedures, like common stored procedures that people make, like when you standardize data or when you want to consolidate data. Because if I'm not mistaken, Redshift and BigQuery are actually free to a certain degree. So you can actually practice your stored procedures there. And I would also say, if, for example, you want to study data flow or maybe Cloud Composer, they're based on Apache Beam, Apache Spark, etc. Apache Beam and Apache Spark are free libraries. So you can build your script on your local laptop without having to provision an environment. So you can go back to the framework that they're using and study that first. And then you can try it out when you're more confident and you provision an environment.
Yeah, thank you for that.
All right, no problem. Thank you.
Okay. Hello. Good morning. My name is Evan. It seems like data engineers are at the forefront of really handling a lot of potentially sensitive data, sensitive to the user in terms of privacy and sensitive to the business for their, strategic capability. Now, given the outline shared so far, my question is how much, or as a data engineer, how do you factor in the security of this information going in and out of the cloud? Or is this something really built into the interfaces, the cloud database we're working with? Is that something you trust 100% instead?
Okay, that's a very good question because data privacy is a hot topic with GDPR and HIPAA and all kinds of laws being passed today. So if you actually end up leaking sensitive data, you can get jailed or fined millions to billions of dollars. So it's actually a very, very good question. Okay, so well, I think that there are two ways to look at it. So the first thing I think you're referring to is if the actual ingress and egress of data between me and the cloud is secure, right? So we have, the cloud has different kinds of encryption. Okay, so what people usually do, what customers usually do, is they design their own network. They have a VPN, if you're familiar with that. They have their own VPN, they have their own environment, and you can only access this environment using a company laptop, which also has a lot of bloatware in there, making sure you don't tamper with it. Okay, so that's the first step. So the second step is that they have very strict encryption protocols. Okay, so encryption protocol, you can either use a managed key, which is built into the cloud providers. Like you can provision your managed keys, or you can create your own as well. Okay. So then the egress and the ingress and egress of data is secured in that way. So now the second way that you can look at it is pagdating niya sa cloud mismo, how do you handle sensitive data? Because even the engineers working on the data are not supposed to see the data. Okay? So on the cloud, we have services that do data masking. Okay? So you have services like data catalog that do the data masking. So it's actually quite nice because you can just give it a few rules and it will mask your data as is. It's as simple as calling an API. So that's how you would mask your data once it's there.
Hello, Jello, tech lead, more of a manager than a programmer now. Boo-hoo. Let's say let's say a startup is, the people at the startup has no clue about data engineering and stuff. What's our first step in data? Again, very naive question. Pardon me. Should we hire a senior data engineer first, or a senior data scientist first, or should we first outsource it to another company? What's our first step in a startup's journey to data engineering? Is my question.
Okay, that's actually a great question. So what I would say is if we're assuming that you have a team and they all have absolutely no clue what data engineering is, well, it is nice to bring in like an experienced consultant, but at the same time, you can train them in parallel in the fundamentals. So fundamentals would be, well, of course you have Python, which I think they would know, and then you would do SQL. So Python and SQL are your like super fundamentals, and they have to be super solid. And then you also have to teach them about the cloud as well. So just general cloud things. You just start with the basics like what's the cloud, and then why do we use the cloud, etc. So those are the fundamentals. And then you can take it a step higher by bringing in a senior consultant to actually show them sample architectures, because what's more important to note, other than the actual technical skill of the person, is if they understand why things are the way they are. Because they're going to be dealing with problems like, oh, the system went down, we're missing resources, or it's too slow, how do we re-architecture this? So they need to, I would say it's good to bring in a mentor to present them with sample cases and then sample architectures so that they understand why things are the way they are, how to make sound technical decisions.
Now we have a tiny bit of time left, so I'd actually like to ask a personal question. So especially for everybody here who's just a student or isn't that familiar with the fields related to data just yet, there's a bit of cloudiness around the different terms used for data roles. So there's data engineering, data analytics, data science. So could you simply explain to everybody how those things differ?
Sure. Okay. So let's start with the data analyst. Okay, I think how you should see it is data engineering and data science is actually, it falls under data analysis. So data analysts do like a lot of general work, and then you could possibly branch down into data engineering or data science. So I would say a data analyst does a mix of everything. So if you're a data analyst now, you would probably do a mix of working on the cloud while doing a little bit of software engineering, while doing a little bit of number crunching. So you could be doing a lot of things. Then when you move on down to the data engineer and the data scientist is the person who does the cool stuff, basically. Like the person who makes the cool ML models and crunches the data and provides business insights. And provides like, an example would be a model that would predict the probability that a certain person will default on a loan. Like that's one example. So usually banks have, they have officers who do that manually, but now we have models that can do that on its own. So data scientists do all that cool stuff, right? Now the data engineer, on the other hand, makes sure that the data scientist can do those stuff by providing good data. Because I've seen it happen before. A lot of companies and startups have ML dreams, data science dreams, but the problem is they don't have the data. It's either there's no data or the data is just way too dirty for it to make any sense. And so, they learn the hard way after months of investment that what they want to do might just be a pipe dream because of the lack of data, the lack of good data. So that's why you bring in a data engineer. So provided that you have data, the data engineer makes sure that it's usable. Okay. So a lot of data actually does not make sense on its own. The data engineer takes it and makes it human readable and usable.